Have you ever really thought about how we describe the world? We're always throwing numbers around, right? How hot it is, how fast we're going, how far away something is. But what if I told you that sometimes a plain old number is only half the story? Well, today we're going to dive into this hidden language that shapes our physical world.
Okay, so imagine this. You're an air traffic controller, and a pilot radios in. All they say is, my speed is 500 miles per hour. So, here's my question for you. Is that enough? Is that all the information you need to do your job and keep everyone safe?
No way. Not even close. 500 miles per hour. Going where? North, south, east, straight into another plane's flight path? Without that extra piece of information, that number isn't just incomplete, it's actually dangerous. And right there, that's the fundamental difference between two concepts that secretly run our world, scalars and vectors.
So to really get what's going on with our pilot, we have to start with the simple part of the story. Let's talk about the numbers we use every single day without even thinking about it. These are called scalars.
A scalar is, well, it's just a number. That's really it. It has a magnitude, a size, an amount, but that's where the story ends. It answers the question how much, and that's all it does.
And you use scalars all the time. Think about it. When you say it's 25 degrees Celsius, you don't need to add pointing up. A bag of flour is 5 kilograms, period. Distance and speed, they're classic scalars. I ran 10 kilometers. The car was going 100 kilometers per hour. They're just simple, straightforward facts.
This is a perfect way to think about it. A speed limit sign is a scalar. It gives you one piece of information, a magnitude, a number you shouldn't go over. But it has absolutely no opinion on where you're going. It only cares about how fast, not where to.
So if scalars are only giving us half the picture, what's the other half? What gives us the full story? Well, this is where the hero of our pilot story comes in, the vector. Remember our pilot? What was missing? It wasn't how fast, we knew that. It was which way. That missing piece of the puzzle, the thing that gives a number its real power in the world, is direction.
And that's precisely what a vector is. It's a quantity that's kind of like a package deal. It gives you two crucial pieces of information all at once, a magnitude and a direction. It doesn't just tell you how much, it also tells you which way.
So here's the key takeaway. You always have to think of a vector as a two-part deal. You absolutely need both to have a complete vector. First, you've got the magnitude, which is just like our good old scalars, and second, you have that all-important direction.
All right, let's make this super clear. You see the number 60 miles per hour. As it is, that's just a speed. It's a scalar. It tells us how fast, but if you're trying to get somewhere, it's basically useless information.
Now look at this, 60 miles per hour, north, bam! See the difference? We have the exact same magnitude, 60, but by adding that one simple word, that direction, we've completely transformed it. This isn't just speed anymore. In physics, this is called velocity. It's a vector. It's the complete story. Okay, so we've met both of our key players, the scalar and the vector. Now let's put them side by side so the difference becomes absolutely crystal clear.
When you see them head-to-head like this, it's actually pretty simple, isn't it? Over on the left, scalars have one job and one job only. Tell you the magnitude. They answer how much or how fast. Speed is the perfect example. But on the right, vectors are doing double duty. They give you the magnitude plus the direction. They answer how much and which way. And that's what makes speed become velocity.
This idea of pairs is really useful. We already nailed down speed and velocity, but look at these others. Distance is a scalar, right? I walked 5 kilometers, but its vector partner is displacement. That's I walked 5 kilometers east. It tells you not just how far you went, but your actual change in position. And this last one, mass versus weight, this trips people up all the time. Mass is just the amount of stuff you're made of. It's a scalar. But weight is a vector. It's the force of gravity pulling on that mass in a very specific direction, down.
Okay, so why does any of this matter? You might be thinking, this seems like a picky detail for our physics class. But the truth is, understanding vectors is absolutely essential to how our entire modern world works.
Vectors are the invisible workhorses running everything behind the scenes. Pilots use them to plot a flight path while accounting for wind velocity. Physicists use them to figure out how different forces are pushing and pulling on an object. Weather forecasters use them to map wind. Even video game programmers use vectors to tell a character how to move on the screen. And of course, your GPS is basically a vector machine.
And you can just see how critical this concept is across the board. From landing a plane safely, to understanding the laws of the universe, to just getting to your friend's house, vectors give us the complete information we need to make things happen correctly and efficiently. Here's the simplest way to think about it. If your GPS only used scalars, it would say something like, okay, drive 5 miles. And you just sit there thinking, great, in which direction? It's the vector calculation, drive 5 miles north on Main Street, that actually makes the whole thing work.
So the next time you check a weather map and see those little arrows showing wind, or you follow your GPS directions, or heck, even just feel the force of gravity keeping you in your seat, remember the vector. It's not just a number. It's a number with a purpose, a number with a direction. So that leaves me with just one final question for you. What unseen vectors are shaping your world right now?